Okay, so I thought I'd show you a simulated example of what to do in terms of doing your robot goals. So here's a really simple one. I'm going to go through the program first and then we'll run it and you can see what it does. So obviously I'm importing Miro. This initializes a simulated robot. This shows me all of my sensors, which I just wanted to monitor while I was running the program. I start out by setting obstacle to the center obstacle sensor. So I get a number for that. And then I have this while loop that says, while this number is less than 500, keep going forward. And then I have to get that number again every single time I go through the loop. I have to check and see if there's something in front of me. So you can imagine this like what many blind people do, of course, is are constantly checking either with a cane or if they're feeling by hands. You have to constantly check to see if there's something in front of you. So that's what the robot does. And I just reset that variable to whatever's right in front of it. If the obstacle gets to be greater than 500, then it will come out of the loop. So it will no longer be in this while loop, and it will come down here and run whatever's next, which is to stop and to tell me that it's stuck. So let's see what that looks like. So here's my simulation, and here's the sensor window up here so you can see it. And it just moves forward, and I made it go slowly so it could, check every single time pretty slowly. So as it gets close to the wall, the light goes down, and you can see up here that our sensor value in the center, this is left, center, and right, is 3200. So it stops, it tells me it's stuck, and then we're good. So that's a really simple example. Okay, here's another simple example. I have down here this is a loop that will run forever while true, and it's always true. And then I check my obstacle in the center, and then if my obstacle is returns a value that's greater than 1,000, it's going to turn right, turn by 90 degrees. Otherwise, it's going to keep going forward. So we didn't talk that much about else in class the other day, but this is what an if statement often looks like. Is you'll have if this is true, then do this. Otherwise, do this other thing. So basically, this says if there's nothing in your way, keep going forward. Otherwise, turn by 90 degrees. Now you could write it, so I check the obstacle every time, and then I check to see what the value is. I could have written this the other way. I could have said if obstacle is less than 1,000, go forward, otherwise turn right. So it doesn't really matter which way you do it as long as it does what you want it to do. So let's see what this looks like. So again, I have my sensor window up here so I can see it. The robot goes forward, and what should happen is it should turn as soon as this center obstacle gets to be greater than 1,000. So it's 3,000, so it's turning. And then it should do the same when it gets down to the corner. So it sees the obstacle and it turns. So there you go, and it will do that all the way around forever. Okay, now I'm going to show you one more example. It's a little more complicated. So we're combining light, getting the light sensor and the obstacle sensor because we're going to have our robot try to get away from the bright light. And we obviously don't want it to run into anything while it's doing that. If it runs into something, we want it to get itself out of the way because otherwise then your light thing is kind of pointless. So let's look at this. So I get my light up here. So I'm getting the light from the center. We can average that out. We talked about that a little bit in class, but for where we are right now, let's keep it simple. So while the light is greater than 500, when you're in bright light, the readings are usually like 4 or 5,000, so having it be greater than 500 is going to make sure that you're definitely in bright light. We're going to have it turn a little bit so that it tries to turn away from the light, and then we're going to check our light again and see if we've turned in a direction that is okay. We're going to check and see if we've turned into an obstacle. And then if we have turned into an obstacle, we're going to back up a little bit and turn and go forward. Otherwise, we're just going to keep going forward. So, and then just for fun, I had it tell me that it's too bright. So what this should do is, as long as there's not an obstacle in the way, it will, and it still needs to get out of the light, it will go forward. So we have two sort of things that we're checking here, our light and our obstacles. So let's see what happens. So we can see our sensors here, and right now our light
too bright in here.
Is at 5,000.
It's too bright
Still
in
too
here.
bright.
It's too bright in here. It's too bright in here.
Okay, so
it's too bright in here. Now I can take a nap.
There we go. So it took it a minute to check its light sensors. You saw it go down pretty quickly, and then but it checked before, so now it's at 410. So since these sensors, the light sensors, are right here on the front of the robot, as soon as the front of the robot is away from our light source, which is over here, then you know, it will decide that it's dark enough for it to take a nap, as it says. All right, one last example that's a little bit more complicated. If you remember in class, I told you that you can get obstacle and it returns 3 values in a list, and that if you wanted to separate out those values, that you could just put your variables here with commas between them, and it will assign each value to the next variable there. So this essentially takes the left, center, and right, and takes the list that gets returned from get obstacle and assigns the first number to L, the second number to C, and the third number to R. So then what do we do with those numbers? So in my if statement here, what I've done is I've added or statements in here. So basically what this says is, if any of the sensors are greater than 0, in other words, if there's anything on any side of the robot at all, take a picture, show me what's in front of you, back up a little bit, turn a little bit. If there's nothing in front of you, if all of those are reading 0, then go forward. And then, of course, we're going to check for obstacles again. So this is a way of, I mean, you could take these and average them out if you wanted to, but I like seeing if there's anything in front of any of the sensors. You don't want the robot to continue going forward. You want it to do something else. So the other thing that I changed that's a little bit different from the other examples is, in the other examples, I had the robot going forward for a certain amount of time. It's a nice thing to do if you want to go slowly and you want to make sure that the robot stops and checks. However, you can also have your robot just continue going forward and assume that it will stop when you tell it to. That usually happens. It doesn't always happen, but sometimes the robot gets a mind of its own and just keeps going. In the simulated version, it's pretty stable. So let's take a look at what this program does in the simulated robot world. And I also have it turning around so that we just get some more interesting effects rather than it bumping into the wall. So we've got our sensors. I'm also going to drag this over here so you can see the camera in a minute. So it's going to turn around a little bit. It's going to go forward. And here in a second it should see this blue ball. So it saw the blue ball, and here's our camera that shows us what it's seeing. And it's going to continue going forward. It's probably going to hit the wall. So it's going forward fairly slowly. And now it's backing up. You can see that it's really does avoid obstacles. It squeaked through there. It's kind of cool. Should back up. So this is kind of a handy way of checking for obstacles. You'll notice here in a second, it's probably going to run into this square. There we go. And now it's running into the wall. Another thing I could do, notice how it's sort of bouncing off the wall, and it's probably going to end up kind of stuck in here. In fact, it is sort of stuck. Yeah, it's not going to be able to go forward. So what I could do is have some ways to solve this would be to, right now the infrared is showing 0. So it's kind of stuck. We could have it, if there's something behind it, when it backs up, which it's showing right now because my infrared is 0, we could put another if statement in there that it needs to turn all the way to the right instead of just by a little bit. So it's going to actually sit here forever because it's just taking a picture of this and it's backing up, but it's not doing anything. So that's just another slightly more complicated example. So I hope that helps you figure out some things that you can do. This kind of program, by the way, right here, is probably all you really need to do for your lab. You don't need to get very complicated. We're going to do something a lot more complicated in terms of using sensors in a couple of days. So keep it simple. Just have it, do something like find an obstacle or, go away from the light. Just something pretty simple. Maybe it finds the wall. Whatever you want to do. And you can have it do slightly different things. And some other sensors that you can use are you can use the camera sensors to get better light sensations. So in fact, let's just check. Right now, the brightness doesn't show up in the sensors window, but if you do a get bright here, you can see it's way down here at the bottom. Let me move this out of the way. You get slightly different numbers than you get for your get bright. And if we turn this robot all the way around, let's make a 180, and then we'll do a get bright again. So our get bright is a little bit different. You can see that we started out at 1942, 1797, 1961, and now we have one that's way up here, and that's coming from the camera. It's a little weird that we're getting this high of a number when it's not facing the light. We can turn by 90 degrees and check it again. And this is one of those things that you can do this and sort of experiment with and see what numbers you're getting. So there again, and it might be because it was facing the yellow, but there was a little bit of yellow there. So you can just experiment, turn your robot around and look at different things and then see what kinds of numbers you're getting and then what you might be able to do with those numbers based on them. Now, in the real world, these numbers are going to be a lot more interesting than they are in the simulated world because you've got a lot of different light levels. And so one thing you could do, so if I do a get light here, so I have, there's a lot of light coming from the center and the right nodes, and there's not a lot coming from the left. So what you could do is say, okay, the light source must be over to the right, so I don't want to go over there, I want to turn to the left. So you could do something like L equals get light from the left. Oops. And then you can say if L is less than 1,000, turn left, and you can decide how far left you want to turn. So it turned left there. So now if I do another get light, now I see that I'm well away from the light. So that might be another thing to play around with. So all I want to see is using one or more of the sensors and doing something somewhat interesting with that, whether it is going away from the light, going away from obstacles, going toward obstacles, Maybe you want to have it go backwards and check its infrared. Just play around with what you get and see what happens. So good luck. I'm looking forward to seeing what you do.